Super Typhoon Yagi nears southern China, threatening Philippines, Vietnam, China with heavy rains, strong winds. The storm has killed at least 13 people in the Philippines and is forecast to be the strongest storm to hit Hainan province in a decade. Super Typhoon Yagi headed toward southern China on Friday, bringing heavy rains and strong winds, closing schools and businesses, and disrupting travel. The storm was upgraded to a super typhoon, with maximum sustained winds of about 150 miles per hour on Friday, equivalent to a Category 4 storm, according to the U.S. Navy's Joint Typhoon Warning Center. The storm is forecast to make landfall Friday evening near Guangdong and Hainan provinces after moving west through the South China Sea. The center said it is expected to become the strongest storm to impact Hainan since 2014. Yagi formed as a tropical storm on Sunday in the Philippine Sea. In the Philippines, the storm dumped about 10 inches of rain this week, killing at least 13 people, displacing tens of thousands and damaging hundreds of homes, according to the Philippine government. China's Meteorological Administration has warned residents of the risk of flooding and storm surges and raised its emergency response to the second highest level. Guangdong province has issued its highest level emergency warning. Some towns in Hainan are expected to see more than 4 inches of rain in the next 24 hours. The province suspended all train and boat trips Thursday and canceled all flights scheduled at Haikou Meilan International Airport from Thursday evening to Friday night. Haikou, the capital of Hainan Island Province, ordered all non-essential services, businesses, public transportation, markets, schools, and construction sites to close Thursday. Authorities in Zhanjiang, a city in Guangdong, ordered similar closures ahead of the storm's landfall. The storm is expected to pass through Hong Kong, a Chinese territory, on Thursday and Friday night. The Hong Kong Observatory urged residents to stay away from the coast, limit outdoor activities, and move small vessels to shelters. Hong Kong authorities closed all kindergartens and many schools on Thursday. Hong Kong Express, a budget airline, said it had canceled 6 flights scheduled for Thursday and Friday. How do hurricanes form? Hurricanes are some of the most powerful and destructive natural phenomena on Earth. These massive storm systems are known for their intense winds, heavy rainfall, and the damage they cause. Though hurricanes are most commonly referred to by this name in the Atlantic and Eastern Pacific Oceans, they are known as typhoons in the Western Pacific and cyclones in the Indian Ocean and Southern Hemisphere. Despite the different names, the scientific term for all of these storms is tropical cyclones, and they form in the same way. Let's break down the detailed process of how hurricanes develop, what fuels them, and the unique characteristics that define them. The birthplace of hurricanes: warm ocean waters. Hurricanes form exclusively over warm ocean waters, typically near the equator, where sea surface temperatures are at least 80 degrees Fahrenheit or higher. These warm waters provide the energy necessary for the storm's development. The formation process begins when the sun heats the surface of the ocean, causing the water to evaporate. This warm, moist air rises upward from the ocean's surface, initiating the process. As the warm, moist air rises, it leaves behind an area of lower air pressure near the ocean's surface. This is because as the air rises, it moves away from the surface, creating a vacuum effect. The surrounding air with higher pressure rushes in to fill the gap. This new air in turn warms, becomes moist, and rises as well. This continuous cycle of rising warm air and incoming cooler air from higher pressure zones is what forms the initial disturbance. As the warm air rises, it cools, and the water vapor it contains condenses to form clouds. This process releases latent heat, which further powers the system, allowing the clouds to grow taller and denser. The Earth's rotation plays a critical role in giving the storm its characteristic spinning motion. Due to the Coriolis effect, storms in the northern hemisphere spin counterclockwise, while storms in the southern hemisphere spin clockwise. This rotation helps organize the system into a circular shape, and as the cycle continues, the storm grows in size and strength. The system continues to strengthen as long as it remains over warm ocean waters. The continuous rise of warm, moist air leads to the formation of towering cloud structures, and the air pressure at the center of the storm continues to drop. As this occurs, the storm draws in more air from the surrounding areas, causing wind speeds to increase. The rotating system now begins to develop a structure with bands of thunderstorms spiraling out from the center. These are called rain bands, and they are responsible for the heavy rainfall and thunderstorms often associated with hurricanes. In addition, these bands carry the strongest winds, which are driven by the storm's rotation and intensifying low-pressure core. As the storm's rotation accelerates, it reaches a critical point where the wind speeds near the center create a very distinct feature: the eye of the hurricane. The eye is the calmest part of the storm, with low wind speeds, clear skies, and very low pressure. Surrounding the eye is the eye wall, which contains the storm's most intense winds and rain. The eye wall is where the hurricane's most destructive forces are concentrated. The classification of tropical cyclones depends on the speed of their winds. When the winds reach 39 miles per hour, 63 kilometers per hour, the storm is classified as a tropical storm. When the wind speeds reach 74 miles per hour, 119 kilometers per hour, the storm officially becomes a tropical cyclone, also known as a hurricane in the Atlantic and Eastern Pacific regions. Hurricanes are further classified by intensity using the Saffir-Simpson hurricane wind scale, which ranges from Category 1 to Category 5. Once a hurricane is fully formed, it moves across the ocean, driven by prevailing winds. These storms tend to move westward due to the influence of the trade winds near the equator, and they can cover hundreds of miles in diameter. As long as the hurricane remains over warm ocean waters, it continues to gather strength by drawing energy from the evaporation of ocean water. The warmer the water, the more energy the storm can absorb, potentially turning it into a more powerful system. When hurricanes make landfall, reach the shore, they usually begin to weaken for two main reasons: loss of energy. Source: hurricanes are fueled by the warm ocean waters. Once they move over land, they lose their main source of energy, evaporation from the ocean's surface. Without this fuel, the storm's intensity diminishes. Increased friction. On land, the rougher terrain increases friction, which slows the storm's winds down. This leads to a decrease in wind speed and overall strength. However, even though hurricanes weaken after landfall, they can still cause significant damage far inland. The strong winds, heavy rainfall, and storm surges associated with hurricanes often lead to widespread flooding, destruction of infrastructure, and power outages. Modern technology has greatly enhanced our ability to monitor and predict hurricanes. Satellites, operated by the National Oceanic and Atmospheric Administration, NOAA, and built by NASA, play a crucial role in tracking these storms. These satellites provide real-time data on the size, strength, and path of tropical cyclones, allowing meteorologists to issue early warnings to affected regions. Advanced computer models, combined with satellite data, help forecasters predict where a storm is likely to make landfall and how intense it will be when it arrives. This technology saves lives by giving communities enough time to prepare and evacuate if necessary. Hurricanes, or tropical cyclones, are powerful storms that develop over warm ocean waters near the equator. They form through a series of complex processes involving rising warm, moist air, low pressure, and the rotation of the Earth. Once formed, these storms can grow into massive systems, bringing devastating winds, rain, and storm surges to coastal and inland areas. Modern advancements in satellite technology and forecasting have significantly improved our ability to predict and mitigate the effects of these deadly storms, helping to protect lives and property. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.